Hi everyone, and welcome to the Introduction to Business Math Module 1. Today we're going to be looking at rounding. And rounding is an important concept in this course for a couple of reasons. First of all, we want to try to avoid rounding throughout our calculations because that's going to give us the most accurate value possible. And secondly, we're dealing with a lot of our answers are in money or percentages, and so we want to make sure that we're able to round those so that they are appropriate for the situation. So with money, we are quite often rounding to 2 decimal places so that our values can reflect dollars and cents. So there are 2 steps to be followed when you're rounding a value. The first thing is to identify the digit that needs to be rounded. So if we're rounding to the nearest 10, we're looking at the digit in the tens place. If you're rounding to 2 decimal places, you're looking at the second digit after the decimal point. And then once you've identified that digit, then you're going to look at the digit directly to the right of it. And that will determine whether you round up or round down. And round down is a bit of a silly saying because we have 2 options. If our digit in step 2, so our right-hand digit, if that is less than 5, so 1, 2, 3, or 4, or 0, that means that our value that we identified in step 1, that digit will remain the same. So we say round down, but it remains the same. If our digit in step 2 is 5 or higher, then we round up. So our digit in step 1 goes up to the next value. So we'll do lots of practicing. We're going to start out with rounding to the nearest 10 and rounding to the nearest 100. So when we're rounding to these place values, we have to remember to replace our drop digits with zeros. So let me show you what that means. So we're going to start out with rounding to the nearest 10. So our first example, 362. If we follow our 2 steps, we identify the digit that we're looking to round, so the 6 is in the tens place here, and the digit directly to the right of it tells us what to do with it. So our 2 tells us what to do with that 6. Because our 2 is less than 5, that indicates the round down scenario, but we don't really round down, we leave it the same. So we keep our 3, our 6 stays the same. And then what we've done is we've dropped that 2. So if we look at our final answer as it stands right now, 36 is not close to 362, and our rounded value should be somewhere in the same neighborhood as our original value. So we need to replace that 2 with a 0. Looking at the next example, we have a value of 57 that we're rounding to the nearest 10. So we're looking at the 5 that's in the tens place, and the 7 will tell us what to do with it. So because our 7 is 5 or higher, that means that our underlined 5 gets bumped up to the next value. So 5 becomes a 6, and we need to remember to replace that drop digit with a 0. So 57 rounds up to 60. And then the last example in this set, we have 1998. And so this one is a little bit trickier. And so sometimes I like to think of this, if we think about rounding to the nearest 10, we can think about counting by tens. So if we were counting by tens, we'd have 1980, 1990, 2000, and 2010. And 1998 would fall somewhere between 1990 and 2000. And so we end up rounding it to 2000, which is what it's closer to. But if we follow our instructions from before, we have our 9 in the tens place. 8 tells us what to do with it. And the 8 will bump this 9 up to a 10, but we don't have anywhere to put a 10, so that actually bumps this 9 up, which becomes a 10, and we have nowhere to put that, so that bumps our 1 up, and we can go somewhere from there. So our 1 will become a 2, and we're going to replace those drop digits to make it 2000. So a little bit of a trickier example, but there's multiple ways to think about how to do this. The next examples are similar. We're rounding this time to the nearest 100. So in our first step, we're identifying the digit in the hundreds place. So that's our 1 here. And the 7 is going to tell us what to do with it. So because our 7 is 5 or higher, that means that it's going to bump our 1 up to a 2. So we keep our first 2, 1 becomes a 2, and then we can't forget to replace our drop digits with zeros. So 2,173, that is nowhere close to 22, which means we've forgotten something. So we have to replace the 7 and the 3 to become 2,200. And our final example here, we have 32,549. So 5 is what we're looking at. 4 tells us what to do with it. And I put this example in here specifically because this is a really common mistake. A lot of students would want to take that 9, which would bump the 4 to a 5, which would then bump the other 5 to a 6. And that's not correct. So when you're rounding, you are looking only at the digit immediately to the right of the one you're trying to round. So we only are concerned with the 4. So we keep our 32,000. Because our 4 is lower than 5, our 5 stays the same, and we replace our drop digits with zeros. We're going to change gears just a little bit and do a different type of example. So we're going to round to the nearest whole number now. And because we do a lot of our work with money in business math, this would also be equivalent to round to the nearest dollar. So we're going to start out with a couple of examples. 458, and if we think of this as dollars, it'd be $458.14. So if we round that to the nearest whole number, we're concerned with the number immediately in front of the decimal, so to the left of the decimal. And the 1 tells us what to do with it. So because our 1 is less than 5, that means that our 8 stays the same. So we have 458. And when we're rounding to the nearest whole number, we do not have to replace those digits after the decimals with zeros. Next example, 322.49. So the second 2 is what we're concerned with. 4 is going to tell us what to do with it. We don't look at the 9. So remember the last example in the round to the nearest 100, only the 4. So that means 2 stays the same, and we're left with 322. One last example, 49.97. So we look at the 9. The second 9 tells us what to do with it, which means it bumps this 9 up to a 10. There's nowhere to put a 10, so that means we're bumping the 4 up to a 5. In this case, we do have to replace one drop digit with a 0. So that first 9 to the left of the decimal place, that one needs to be replaced. Any numbers to the right of the decimal, when you're rounding to a whole number, those do not need to be replaced. And the last and probably most important type of rounding we're going to do is rounding to 2 decimal places. So when you're asked to round to a specific number of decimal places, you're looking at that digit after the decimal. So when we say 2 digits after the decimal, we're looking at the second digit after the decimal point. If it were 3 digits or 4 digits, you'd be looking at the third or fourth digits after the decimal. And we can also drop any additional digits, so we don't have to replace with zeros in this type of rounding. So if we look at our first example, 152.623, we're looking at the second digit after the decimal. The one immediately to the right tells us what to do with it. Because our 3 is less than 5, that means our 2 stays the same. So we round this to 152.62. Next example, 13.4574. I'm looking at the 5. 7 tells me what to do with it. 7 is 5 or higher, so that means I keep my left-hand digit, 13.4, and my 5 becomes a 6. Third example, 27.1034. I'm looking at the 0. 3 tells me what to do with it. 27.1. And because our 3 is less than 5, that means our 0 stays the same. We don't have to replace drop digits with zeros, but we should keep the 0 here because this is indicating that decimal place is a 0. So often we do this because we're working with money, and so this represents $27.10. And the final example in this set, 34.999. So this is one of those examples where we're doing a lot of bumping. Okay, so we have our 9, bumps the 9, bumps the 9, bumps the 4. So this becomes 35. Now we don't have to replace those drop digits, but we are trying to round to 2 decimals. So we should have 2 digits following the decimal place, which means that we keep those 0, 0. So we don't have to replace anything after 2 digits, but we should keep those zeros to represent 2 decimal places. So for this course, we have some rules for rounding. I don't know if rules is the proper term. Guidelines might be more appropriate, but they're still important to ensure the accuracy of your answer. So whenever possible, don't round until your final answer. Try not to round in the middle of your calculation because as we get into more complicated mathematics, this can cause your final answers to be off, sometimes by quite a bit. If you are struggling to, keep all of the decimal places, try to keep more than you need. So 6, often if we're ending up with 2, keeping 5 or 6 decimals throughout your calculations, if you do need to write down those intermediate steps, then that will help to keep your final answer as accurate as possible. And we round our final answers in this course. So this is very important, and you will lose marks if you are not doing this properly. So anything that is a currency answer, so dollars is a big part of what we do. So we want to represent dollars and cents. We want to be rounding these to 2 decimal places. Other values such as percentages, so we do a lot of work with percentages as well. 2 is a great guideline here. 2 decimal places is wonderful. In this case, more decimal places would be acceptable. More is typically better than less. So 2 decimal places, get used to that rounding because you're going to be using it a lot throughout the course.